Hello students, this is Dr. A.S. Ayyar. I welcome you all for the course on finite element method in civil engineering. Our today's topic is 2D and 3D Pascal Triangle. We will also discuss in this class what is geometric isotropy, which is also called as geometric invariance. So what is geometric isotropy or geometric invariance? In the finite element analysis, when we represent the approximate variation of displacement with the help of polynomial expansion, while representing this polynomial expansion, the convergence and compatibility are the important requirements. But besides this convergence and compatibility requirement, there is one more important consideration while representing or choosing the proper terms in the polynomial expansion is the element should not have any preferred direction. The element should not have any preferred direction, which means whatever displacement shape is there in the element, that displacement shape should not change if you change the local coordinate system. The displacement shape should not change if there is a change in local coordinate system. It means we can represent the local coordinate system either with the help of Cartesian coordinate system or with the help of natural coordinate system. So whenever we are representing any polynomial expansion, if we change this Cartesian to natural or natural to Cartesian coordinate system, there should not be any change in the displacement shape. This property of the element is called as geometric isotropy, or which is also called as geometric invariance. It means displacement shape should not change with the change in local coordinate system. This property is known as geometric isotropy or geometric invariance. Now, the geometric isotropy or geometric invariance can be achieved by selecting the proper terms from the Pascal triangle. Now, what is Pascal triangle and how to write down the Pascal triangle? So, Pascal triangle is either two-dimensional or three-dimensional. So one by one we'll discuss 2D and 3D, both the Pascal triangles. So in 2D Pascal triangle means it is represented in XY coordinates only. There is no Z coordinate in 2D Pascal triangle. So there is only XY coordinates. So first point in the Pascal triangle, if you look at this, it represents the constant term. It represents the constant term. So normally it is represented by 1. Okay. So in the second row of this Pascal triangle, it represents the linear terms. Linear term means maximum degree of variable is 1. It may be x or it may be y. The maximum degree is 1. Or you can say that if you select a combination of x and y such that the sum of degree of these two variables must be equal to 1, right? So we have to identify such combination of x and y. If you add the degree of these two coordinates, the sum of that degree must be equal to 1. So the first option is, first probable combination is, if you write down x raised to 1 into y raised to 0, if you look at this, so 1 plus 0, the sum of degree is equal to 1, right? Now x raised to 1 means x and y raised to 0, anything raised to 0 is equal to 1. So x raised to 1 and y raised to 0, the answer is equal to x. Our second probable combination is x raised to 0 and y raised to 1. So answer of this, x raised to 0 is 1 and y raised to 1 is equal to y. So its answer is y. right? So these are the only two combinations are possible where sum of degree of these two variable is equal to 1, right? So that's why the first answer x is written here. It means here y is equal to 0, and here y, second variable is y, it means x is raised to 0. So no need to write down that raised to 0 term, and that's why only xy is written. Okay, so that's why second row represent x and y. In other words, we can understand this when we write down, when we start to write down these terms in the rows. First we have to write down the maximum degree of x variable and y degree is 0. Then we decrease the power of x by 1 and we increase the power of y by 1. It means here x raised to 1 and y raised to 0. If we decrease the power by x by 1 means it is x raised to 0, and increase the power of y by 1 means y raised to 1, right? So this x raised to 1 into y raised to 0, answer is x. Similarly, x raised to 0, y raised to 1, answer is y. Okay. Similarly, if you look at the third row, which represent the quadratic term, third row represent the quadratic term. So quadratic means maximum power is equal to 2, right? So we'll start with x square here, then decrease the power of this x square into, actually it is y0, right? Now decrease the power of x by 1, so instead of 2 it is x raised to 1, and increase the power of y by 1, so instead of 0 it becomes 1, right? Again we reduce the degree of x by 1, so here it is x raised to 0, and increase the power of y by 1, so here it is y square. That's why it is x square, xy and y square, third row, which represent the quadratic terms. Similarly, third, which represent the cubic term, cubic. So it start with x cube, then degree of x is reduced by 1, it is x square here. Degree of y is increased by 1 from 0 to 1 here. Then again degree of x is reduced by 1 here, from x square to it is x, and y raised to 1 become y square. Again degree of x is reduced, it is x raised to 0, and degree of y is increased, y square to y cube. Similarly, we can write down fourth order term, x raised to 4, then this become x cube here. This y raised to 0 in the first term becomes y raised to 1 here. This x cube become x square, this y raised to 1 becomes y square. This x square become x, y square become y cube. This x becomes x raised to 0, means 1, and y cube becomes y raised to 4. So while writing the Pascal triangle, how to write down it? First term is constant. The second term is linear, means degree, maximum degree is 1. Then in third row it is quadratic, means maximum degree is 2. Then in fourth term it is maximum degree is 3. Similarly, you can increase up to nth order, right? Then degree of x is reduced by 1 in all rows. Degree of x is reduced by 1, and degree of y is increased by 1. So initially in all rows, first term is y raised to 0. First term is y raised to 0. So degree of y is increased by 1. Here it is 2, it is 3, it is 4, like this. And degree of x is reduced by 1. So like this we can write down the Pascal triangle, right? So since it is only in terms of x and y variable, it is called as two-dimensional Pascal triangle. Okay, already we have discussed what for this Pascal triangle is used. This Pascal triangle is used to achieve the geometric invariance. Now 3D Pascal triangle. So concept is same in 2D and 3D. Only the difference is now here we have to deal with the x, y and z coordinates. Right? X, y and z coordinates. That's why it is called as 3D Pascal triangle. So first term is constant, which is 1 again, similar to 2D. Now in second term, second part of this triangle, it represents the linear term. right? So we have to identify combinations of x, y and z such that sum of power of all these three variables, sum will be equal to linear means 1. Sum of power is equal to 1. So which are the probable combinations among these three variables so that sum of power is equal to 1? So those combinations are x raised to 1 and y raised to and z raised to 0. This is the first option. There is one more option, x raised to 0, y raised to 1 and z raised to 0. Or third option is x raised to 0, y raised to 0 and z raised to 1. If you look at all these three combinations, the sum of power or degree of these three variable is 1 in all three cases, right? So what is the meaning of this first term? Y raised to 0, z raised to 0 means its answer is x. Answer of second term is y because x and z are 0. And third term x raised to 0, y raised to 0 means 1. So third answer is z. So three coordinates which represent the linear term is x, y and z, right? So like 2D Pascal triangle, if you look at the 2D Pascal triangle, like 2D Pascal triangle, this first row between x and y, these are as it is in 3D Pascal triangle. If you look at, this is xy, this is x square, xy, y square. Only we have to add the third variable here, like x, y, third variable will be z. Now if you look at the third part of this 3D Pascal triangle, it represents the quadratic. There are 6 terms in this quadratic. So quadratic first row, this row if you look at it is similar to 2D Pascal triangle. X square, then power of x is decreased by 1, x, and power of y is increased by 1. So x square, xy, y square. Now there are two other combinations between y and z because third variable in 3D is z. So if you look at these two combinations like first x and y, if here it is y square and one more term is of z is maximum degree is 2, that is z square. So between these two is yz, like here it is xy, right? And if you look at the combination of x square and z square, the middle term will be xz. So like this you can remember the 3D Pascal triangle. So third part of this 3D is quadratic term which represent the 6 elements. Similarly, now if you want to write down the cubic part of this 3D Pascal triangle, it includes the 10 elements. For example, again if you look at the horizontal part, first combination between x cube and y cube, since it is a cubic term, the maximum power of x and y will be 3. So we start with x cube and y raised to 0 actually, and then degree of x is reduced by 1, degree of y increased by 1. It is x cube, then x square y, then xy square and y cube. And again we have to now find out the combination of z cube and y cube. So between these two, like these two, x square y and xy square, between y cube and z cube, the middle combinations are z square y or yz square. Then between this x cube and z cube, these two combination, the middle term will be x square z and xz square, right? And there is one more probable combination where, since the third part, this third part represent that cubic term. Cubic means sum of power of this 3 variable is equal to 3. Sum of power of this 3 variable is equal to 3. That represent the cubic. If you look at the all term here, it is 3. Then 2 plus 1, 3. 1 plus 2, 3. Here 3. So same is the other combinations. So there is one more combination is possible where sum of degree will be 3, and that is all 3 will be equal to 1. So 1 plus 1 plus 1, the degree, sum of degree will be equal to 3. So there is last 10th combination is xyz element, which is written at the middle. So there are 10 elements where the sum of power of this variable will be equal to 3 cubic. So like this we can increase even x raised to 4, x raised to 5 in Pascal triangle. Now in both these 2D as well as 3D Pascal triangle, the vertical axis is called as axis of symmetry. This vertical axis is called as axis of symmetry. It represents that on the either side of this axis of symmetry, similar number of elements are present. And this is very important while writing the displacement function. We should maintain the symmetry of triangle. How to maintain it, that we'll discuss when we'll discuss about the how to write down that polynomial function or displacement function for the element. Right now in this class you please understand how to write down the Pascal triangle, 2D as well as 3D Pascal triangle. Okay, I hope all of you understand the 2D and 3D Pascal triangle. In the next class we'll see the next article. Okay, thank you very much.